Okay, let's talk about SQL read operations. So I've shown this code in all of those queries for joins that use this function pd read underscore SQL underscore query to process the query. Let's talk a little bit about how that works. It requires a package called SQL Alchemy, and it looks a little intimidating, but it is the most useful package for working with any kind of database. It requires the create underscore engine function. And without getting into too much detail here, the create engine function is where we specify syntax that tells Python, and specifically pandas, where to find the database server on your computer, and within that database server, how to access it, what's your username, what's your password, and then of all the databases that exist on that server, which one do you want to access? So you can see here, I give it my username, I give it my password, and I give it a database. And so the instructions for creating an SQL Alchemy engine for different database management systems are on this website. So docs.sqlalchemy.org, right? And so you could see it, and it works with pretty much anything. So if you're working with MySQL, there's functionality for MySQL. If you're working with Oracle, there's functionality for that as well. Once you have created an engine, and so here I've named it engine in Python, then you can use the pandas function, read SQL query, which takes two arguments. First, the query, so I just wrote, give me everything from the NFL data. And then con stands for connection, equal to the SQL Alchemy engine. And so this is what I'm going to use for all of the read queries we're about to talk about. Now, when we read data, it's not just about extracting data. It's about cleaning and manipulating that data at the same time you read it. There's a number of things you can do to clean and manipulate data. First, you can select the columns that you want to include in the output. You can say explicitly, give me this and that and the other. You can filter. That means subsetting or removing rows based on logical conditions. So you could say, here's a logical condition. Give me all the rows where this is true. You can sort. You can change the order of the rows that appear in the output. You can change the names of the columns to make them more readable and useful. You can do transformations. You can create or modify columns using a mathematical function or a string operator. Or you can aggregate. You can collapse to one row per group, or you could summarize using summary statistics. So I'm going to show you examples of all of these. And it's better to show you code than to just tell you about it. So mostly these are going to be examples. So to choose only a selection of columns, use the following syntax. It's select and then either a star to get everything, or put the names of the columns you want separated by commas. So here's an example. So for all of these, I'm going to be using the example of the wine reviews that we worked with last week. So here, I'm saying that I want to read data from the reviews table. And then from the reviews table, I want to extract the title and the variety and the price and the points. All of these are coming from the reviews table because I've aliased it as R. So reviews, 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 reviews. But I'm also interjoining it to two different tables. So the location of the winery, which is now L. From the locations table, I'm extracting the country name. And then I'm joining it to the tasters table. And from that, I'm extracting the taster name. And so I have title, variety, price, points, country, and taster name. And so that's how it works. The important point here is that the columns you select do not have to come from the data that you write here under from. You just have to give it the proper alias in front. That's very important, especially when you are joining. Okay, to filter rows, we're going to use the where clause, and we're going to supply a logical condition. Now, we don't have time in this video to get into all of the logical operators and how they work, but there is a long list of those in the notebook, so please read the notebook carefully. The other thing to understand about where is that if you use a column in where, it will not display in the output. The clause that displays columns in the output is select, like we just talked about. So don't forget that just writing something in where doesn't mean it's going to appear. So here's an example. This is the same query that we had before, but I'm adding a where clause to it. So if we look at that last line, I'm saying where, that is, restrict the output only to certain rows. I only want the rows where the wine comes from France, where it was reviewed and tasted by Roger Voss, and where the score was 100. Okay, so Roger Voss is the most famous wine reviewer out there. And I want all the French wines that he scored 100. That's just the kind of wine drinker I am. And so all of these down here are wines from France that Roger Voss scored 100. But notice that country doesn't appear, and Roger Voss's name doesn't appear, and the score doesn't appear. And the reason is I didn't put those on the first line. All I said on the first line was give me the title and the variety and the price. So that's an example of using a logical condition. Now there are many other logical conditions and many more examples in the notebook. Please take a look. Sorting rows uses the order by clause. So you have to write one column. You could write a second or third or fourth column. That's optional. If you write a second column, it's used to break ties between values of the first. And if you write a third column, it's used to break ties between rows that have the same value for the first and second columns. Now, by default, when you sort the columns, when you sort the rows, it's in ascending order. But if you want descending order, then you type DESC immediately after the column name in order by. And so here's an example. So in this one, I want the title and the points and the price of wines, where in order to use the location, I use an inner join with location, and then I restrict it to only Virginia wines. And then I want to sort this by points, from highest points to lowest points. But then within points, I want the lowest price first, right? So the top-rated Virginia wine is from King Family Vineyards, which is a really nice place. You can get out there at some point if you want to. Okay, renaming columns uses the as clause. So that comes in the select clause immediately after the title, the name of the column you want. So in this query, I want the title and the variety and the points of all the wines, but I want to rename the column. So instead of title, I want it to be name. Instead of variety, I want it to be type, and instead of points, I want it to be score. And you can see here, name, type, and score. However, if you're going to use where as well, then you have to use the old name. You have to use title. You have to use variety, and not the new name. You can't use where name equals or where type equals. So values that you query with the read function, those values can be transformed using math functions or string functions. So math functions are like taking the exponent of values, taking the square root, taking the logarithm. String functions are turning everything to uppercase, concatenating, taking substrings or trimming. And again, just like with the logical operators, there are full lists of these transformations in the notebook. So please look at the notebook for examples of how to use all of them. Now, the way we use these transformations is within the select clause. So currently, a US dollar is worth 0.91 euros, so 91 euro cents. And so I wanted the price of a wine in dollars, but also the price of the wine in euros. And so what I did was I queried, I want the title, I want the variety, and then I want price as price dollars, and then I want a transformation of price times 0.91, and then show me that as price euros. And that way I could have the price in dollars and the price in euros. So that's a simple math function. Now here's another one. This is using something called case. This is used for taking a continuous numeric column and creating from it categories with names. And so give me the title and the variety and the price, and then I'm going to use case here. I'm going to say when price is less than 20, give me a value of cheap. And when price is between 20 and 50, then give me a value of moderately priced. And when price is greater than 50, say it's expensive. If it's anything else, give me null. So these three conditions will cover all the numbers, but some of the prices aren't there because the prices were never collected in the original data. So basically, it's going to be null if the price just wasn't available. And then end. This end is the end of the case syntax. And then as price level. So this whole thing for case gives me price level. And so you could see for 35, price level moderately priced. 11 is cheap. Okay, and then this one uses the string function concatenate. And so what I wanted to do is I wanted to concatenate the province, a comma, and the country as place. And so I'm creating a column here, place, that has the province, comma, country. So there wasn't anything in the original data that said Burgundy, France, but because I'm using concatenate, a string function, it now says Burgundy, France in the output. So those are a few different ways to transform values. A couple more topics. First, data aggregation. If there are columns in the data output that have repeated values, then each distinct value forms a group in the data. Now there are things we might want to do with those groups. We might want to do data aggregation, which means we're going to collapse the data to one row for each group. So all of those rows that existed for that group are going to have values, and we need to summarize those values. And we can use a summary statistic like the mean of all those values, or the sum, or the count, or we could use a different statistic. Aggregating data, it requires more attention to the ordering of clauses than we have to pay attention to in other tasks. And so I strongly encourage you to look at the examples because we don't have time to explain this well in this video. But very quickly, let's talk about a few examples. So here, I wanted to know what countries had the highest rated wines on average. So I issued a query, and we'll talk about the query next, but it tells me that Austria has the highest rated wines, followed by Germany, the US, France, Italy, and Australia. Now, how did I get to these average points, right? Well, I selected country, and that gives me country. And then down here where it says group by country, having count greater than or equal to 500. So I wanted to collapse the data to the countries that have at least 500 wines. So what do I do with the values within each country? So I created average points rounded to one decimal place, and I wanted to call that average points. And then give me the count as the number of wines. So how many wines were reviewed from Austria? More than 3,000 with an average score of 90.1. So that is one example of using data aggregation. Finally, the last topic for read operations is a subquery. Now, an SQL subquery is a full SQL query that gets used inside another SQL query. Now, there are three types of subquery, and I'll show you examples of each. There's a subquery that yields a single data point, and that's useful if we want to use that data point for something like where, right? Give me all the rows that are bigger than this data point, for example. we have subqueries that yield a list of values. So value 1, value 2, value 3. And that's useful if we're going to use the in operator in a logical statement in where. And I'll show you an example of that. And then third, subqueries that yield a full data table that can be joined to existing data tables. Okay, so first, a subquery that yields a single data point. So here, I'm selecting the title and the variety and the points, but I'm creating also this column, points Z. This is the z-score transformation of points. This is how many standard deviations above or below the mean 93 points happens to be, right? So I'm creating a transformation, and this transformation contains two subqueries. At the end of this whole thing, I'm going to call it points Z. But we start with points, and then we're going to subtract, and then from this parenthesis to this one is a subquery. So you could see here I'm saying select again from reviews, and I'm just saying give me the average points. So the average of points from reviews. So points minus the average. And then I'm dividing by another subquery in these two parentheses. In this case, I'm selecting the standard deviation of points. So I could have gone through and calculated for myself the average and the standard deviation of points, and I could have entered in those numbers myself. But here I'm telling SQL to do the calculation for me using two subqueries. For the second example, for a list of values, I have a subquery that begins here and ends here, right? So where winery ID is in. What this is doing is it's giving me all the wineries that have at least 100 wines. I want to know the big producers. So I'm selecting the winery ID and the title and the variety and the points and the price from reviews. And then I'm restricting it. So I don't want all of them. I only want the ones where the winery ID is in. And now I'm using a subquery to specify that list. So I'm looking at the winery IDs from reviews, and then I'm grouping by winery ID, and then I'm counting. And then I want only the ones that are at least 100. So this subquery gives me a list of winery IDs, and then I'm restricting the overall data to just those winery IDs. And so this is how I get to a data table of only the big producing wineries. Okay, finally, a subquery that yields an entire data table to be used in a join. So I'm selecting title, variety, points, price, but then I'm interjoining. Instead of interjoining to another table, I'm interjoining to a subquery with an alias. I'm calling it B. So what's happening in this subquery? So I am grouping by winery, and I'm looking at the maximum points by winery. So this is going to give me a data table with two columns, just winery ID and max points. So, and then I'm going to merge by winery ID and then filter the data where, so that the points are equal to the max points. Now, I know that's a mouthful, but what this does at the end is it gives me the top rated wine for every winery. So those are all the techniques for SQL. Again, there's a lot more detail in the notebook, and I strongly encourage you to read that closely. I also did not have time in these videos to get into MongoDB, which has its own query language and can even be used to build a search engine. So please read the notebook and learn all about MongoDB as well.